Hi everyone, welcome back to the third video on measurements. Today we're looking at three of the most commonly, or I should say, three of the easiest shapes to look at: the rectangle, the triangle, and one you might not have heard of before called a kite. And we are going to be mainly focused on area in this video. So, as we discussed in the last video, area is a measure of the amount of space on the inside of a shape. So if I got a brush and painted the inside of this shape, that would be the area. Another quantity that you've met before in measurement is called the perimeter. And this is like how far you would walk to go around the outside of the shape. Okay? The diagram doesn't really do it justice because really I have to be very, very close to the exterior. So I'll just say that's the perimeter. Start there and finish there. Now, in the textbook work, we are just concerned with area. So we're not going to worry about how far to walk around the outside. We're just concerned with how much space is inside the shape. So with that, let's get into it, and let's start with the simplest shape, the rectangle. So the question that I want to pose for you is, suppose I give you this rectangle with dimensions 2 meters by 3 meters. What's the area? And what I'm really asking is, how many square meters can I fit inside this rectangle? To help you with this, I have drawn a second diagram on the right here, where I have split it up into 1 meter by 1 meter squares. So each individual square here has area 1 square meter. Refer to the previous video if you're not sure what I'm talking about. So how many are there? Well, if I count the squares, there's 6. And I can get this by noting that there's 2 down and 3 across. And so if I do this calculation, I get 2 times 3, which gives me a total of 6 square meters. And that's how I would do the calculation. In general, if I have a rectangle with length L, L tends to refer to the longer side, and width W, which tends to refer to the shorter side, then the area, often denoted by the symbol capital A, is given by length L multiplied by width, or length times width. And sometimes this is written as A equals LW. And the reason for this is, if I write 2 pronumerals or 2 letters next to each other, like this, what's implied is this multiplication sign between the two. Okay? For clarity's sake, I suggest you include this in your notes. Include the multiplication sign so that you're confident on what you need to do. Okay? So for any rectangle, if I tell you the length and I tell you the width, all you need to do is multiply those numbers together to get the units. And of course, you'll have to match the units given in your answer as well. So that's rectangles. That's the easiest shape to deal with. The next shape that we want to look at is the triangle. Now, the triangle looks a bit different, but here's the insight I want to give you. Every triangle can be thought of as, drum roll please, half of a rectangle. So let me show you this in these pictures. Suppose I gave you a triangle with a base length, so base meaning the bottom, B, and a height, H. That's how tall it is. Now I claim that if I draw a rectangle with length and width H and B, I get half the rectangle if I draw a line connecting the opposite sides of the rectangle. So what I'm basically saying here is the yellow area is the same as the blue area. So if I add the two together, I get the rectangle, and so the yellow area is half the full area of the rectangle. Is that okay? If I split the rectangle in half, I get the triangle. Therefore, the triangle area is half of the rectangle area. But what if I didn't draw the triangle like this first one? What if I drew the triangle like this? Well, what I'm going to need to do is again draw the rectangle with dimensions B and H. And hopefully what you're seeing here is, for every yellow triangle, I can draw a blue triangle. So here are two triangles with the same area. And I think I'll just do this in the same color. Here's another triangle. This one's larger this time. I'll color that one in yellow. And here's another triangle, which is larger, and I'll color that one in blue. And what I'm saying here is the following. These two triangles have the same area, and these two triangles have the same area. Therefore, if I split up the rectangle into yellow and blue, the yellow and blue areas are the same. So this triangle here is half of the rectangle. Now, you might be wondering about the third picture. How on earth do we demonstrate this one? Well, I'm actually not sure. So ask me about this one in class, and we can do some research together and try to develop a similar argument to the one shown for these two triangles. But my claim is, even for a triangle like this one on the right, we still get half the area of a rectangle with dimensions B and H. So we just need to be a bit careful here. It's not this, it's actually this, because I just look at the base and the height. So this rectangle in purple is double the area of this triangle. But it's not immediately obvious to me why this is the case. So feel free to ask me about it in class. I actually don't know at this point in time, but I can look it up if you want. So, in general, if I know that the triangle has base, B, along the bottom, and height, H, meaning the triangle is H tall, and I know that to get the rectangle, what I need to do is multiply the base and height to get the rectangle, what I need to do to account for the fact that a triangle is half a rectangle is take the area of the rectangle, b times h, and multiply it by half. So the reason why we have half in the formula here is because we're saying the rectangle has area b times h. And it is half of that rectangle. So I need to multiply by half. Okay, last shape. This is a kite. Now, you might think, I see a bunch of triangles, so let's split the kite up into 4 triangles. But we can actually do something even easier than that. Suppose I know that this length here, from one corner to the opposite corner, I don't know that there's a name for it. I'm just going to call it x, okay? And I know from the other corner to the opposite corner, the distance is y. I claim that this is the same as half of a rectangle with dimensions x by y. So here's a rectangle. And what I'll do, like we did before, is I'll color in a yellow rectangle for every, a yellow triangle for every blue triangle. So you should see those two are the same. These two are the same. And by similar arguments, these two yellow triangles are the same as these two blue triangles. In other words, a kite can be thought of as half a rectangle. So if I define my rectangle to be x by y, then to account for the fact that my kite is half of the rectangle, I need to take the area of the rectangle and multiply by half, just like we did for the triangle. So here's a rectangle with area x by y, x times y, and I multiply it by half because of the picture that I just showed you in blue and yellow, and that's what the half is for. All right, let's finish with an example of each shape. So here we go. In the first example, I have got a rectangle with length 5 and width 3. The area of a rectangle is given by L times W, which is 5 times 3, which gives me 15. But I'm not done. I need to give a unit. And in this rectangle, the dimensions were meters and meters. So my unit is going to be square meters. So I need to write m to the power of 2. Don't forget to write the units because your answer is not finished unless you write the units. Okay, second example. Here, I've got a triangle with a base, B, 10 centimeters, and a height, H, of 6 centimeters. So B equals 10, H equals 6. The area of a triangle is half times the base times the height. So now I can substitute those numbers in. Half times 10 times 6. 10 times 6 gives me 60. If I halve that number, I get 30. Now here, the units were centimeters. So now my area is going to be measured in square centimeters, or cm squared, or cm to the power of 2. Always check your units with the units you were given in the question. Okay, last one, the kites. It doesn't matter which one we call x and which one we call y. I'll just call 8x, and I'll call y 3. And the area of a kite with dimensions x and y between opposite corners is given by half times x times y, because it's half of the rectangle on the outside. This gives me half times 8 times 3. Half of 8 is 4, and if I multiply 4 by 3, I get 12. The units I was given was millimeters. So now my area is going to be 12 square millimeters. Thank you for watching, and I'll see you in the next video where we will look at, I believe it's circles. See you then.